We are not ready for what's coming. And we need to think about our next steps very carefully, lest we all get lost in the darkness.
We're going up!
Get me into space.
Hey, good to see you. And just wait. I know how it looks.
Anything.
Yeah.
A kilometer underground. Anything is going to be harmless there.
Yeah.
You work for an AI, and then an AI wire transfer you funds into your account, and then you have a machine daddy.
Oh, yeah, your download speed is fast today.
Kyle Hill, everybody! He's the next generation of science communicator.
We are here on set to find the next generation of people to do just that.
This is a nuclear reactor, and it's made out of glass.
Thank you all for having me. If you told me that the Thor that you bought off Temu would be here at the IAEA, I wouldn't have believed you.
Great science and cutting-edge science creates amazing art and science fiction and ways to push our thinking in society further. This radioactive piece of trinitite, a tangible timestamp of the millisecond that we entered the nuclear age.
Are you the monarch? Because I'm crowning.
You can't irradiate the radiation.
Tell you a nice joke. A robot walks into a bar.
No!
How do you look more CP
What's the
than me,
advantage?
though?
What's the utility? Why is this fun? Look at all that crap on the screen. Sick. Oh, I can't believe I pre-ordered the premium edition. Well,
I'm a little afraid it's too matchy-matchy, but Chad, I do like it.
Get in, get nerdy, get with your boy here.
Learn, play, and win the science victory.
Kyle Hill in the chat. Oh my God, that guy's hot. It's like Legolas from Lord of the Rings.
2 chicken tendies. No. Hold the chicken.
chat. Welcome. How's everyone doing today? Hope everyone has had a great day. Sorry that I didn't get to this little follow-up topic a little bit sooner. And I also pre-apologize for probably coughing throughout all of this. I've been bedridden for the last 2 weeks after a failed genetic transplant. I was trying to glow in the dark like those cats they put jellyfish genes into, but it didn't take, and instead I was coughing my lungs out for 2 weeks, so I apologize if I sound a little... if I'm a little short of breath or something like that. But chat, today we're doing a little bit of a special emergency follow-up episode. Since we made a space data center episode, and since the SpaceX IPO came out, I've been getting a lot of comments, a lot of messages, most of them saying how dumb I must look now, saying that basically SpaceX figured it out and I'm stupid and orbital data centers make total sense now. So we are here to reevaluate that claim since SpaceX is going a slightly different way than what we were talking about in that first video. In that first video, we were talking about large orbital data centers, like a international space station size thing, but instead SpaceX is going for many small satellites trying to equal all of that compute, and that's what we're going to talk about today. As usual, when we talk about controversial topics that involve controversial people, my security team, the Bucket, the Crispy, the Chompy, they were going to be on guard with laser bees today. If everyone is cool, we will be talking to chat. We'll be taking your questions. We'll be talking about whatever you want to talk about. But after I show you the little presentation that I have made. So hold on to your really good questions. And as long as we're all cool here, even if you disagree with me, even if you think I'm a big old stupid head, save it and we'll get to it. All right. Because they have itchy trigger fingers. And bees have more than one of those. They got 6 times 2, so like 12 itchy trigger. Just be cool. And we'll get to all of your physics questions, all of your space-related questions, after I get to through my little presentation. So I'll probably also cut this beginning off of this live stream if you like what we're about to go through and what I have to say and my thoughts on it. If you want to share it afterwards, but let's get right into it. Do you like that? That's from Mass Effect. All right, Chad. So today we are talking about orbital data centers that SpaceX made a big part of their IPO, the largest in human history. $1 trillion company, $1 trillion CEO of that company. And since that came out, all of you, hello. I've been getting a lot of emails and comments. I wrote some of them down. Hey, Kyle, guess you're wrong, huh? You think you know more than SpaceX engineers? This aged poorly, LOL. Never thought I'd downvote a Kyle video. I trust Elon more than I trust this guy. And I said, why? And they said, 1 trillion reasons why. He didn't get to where he got by being an idiot. I've never heard an appeal to wealth before. Like, I've heard of, like, appeal to authority and popularity as logical fallacies. I've never heard of appeal to wealth before. Which is I just found that interesting. So if I had more money, I'd be right. Doesn't matter. And none of that matters. What we're going to get to is the brass tacks of the facts of orbital data centers in space. This is all because I made this video, and now people are commenting on it with comments like this, saying that I need to reevaluate everything that I am thinking. I said, to be clear, before we start, I said that large orbital data centers, like putting one of those big flat data centers you see being built out in your country, putting one of those in space is still a silly idea because of how much a problem heating and cooling is in space. It would be a logistical nightmare. But SpaceX is doing something different. As part of their IPO, they announced that SpaceX wants to instead break up all this compute into many, many thousands, up to 1 million satellites in low Earth orbit and other orbits, of course. So while this news is still radiating heat, let's do a little bit of a follow-up, shall we? Is this plan for SpaceX technically possible? Is it practically economical? Is it safe? Does it make sense to do? Again, I will be reading chat, but a little bit after we go through my little presentation that I made. I've been working on it for like a week while I've been dying of genetic anomaly. So, if everyone stays cool, like I said, we'll get to it a little bit later, okay? So, first thing we have to do is go to space. Yes, space. The final frontier for the shareholders. Yes. Data centers in space, like the Jupiter brain I have right next to me, which at this scale is kind of insane if you think about it. How big that would have to... Doesn't matter. This idea of data centers in space, since it came out, has been nearly universally criticized by scientists and engineers, not because it's impossible, but because the fundamental assertions and expectations made by people like Elon Musk seem to be consistently ignoring or at least downplaying reality, and that annoys scientists and astronomers and engineers. And me, also. So, for example, with the heating and cooling problem in space that everyone keeps coming back to as a first approximation of why this idea might not hold water. Scientists continue to have a problem with what Musk says publicly, because heating and cooling in space is literally the biggest problem about operating a machine like this in space. For example, in the still of the IPO video that he put out ahead of last week's offering, he said, quote, "Space cooling is free. You just put a radiator on the dark side of the satellite." Now, look, as I said, as an engineer, from an engineering perspective, it's weird. It's weird that he keeps repeating this with some amount of nonchalance, okay? Because space is literally one of the hardest places to reject heat to that humans can access. I mean, we have some like mines underneath the surface of the earth, like down a mile where it's like 140 degrees, where it's hard to get rid of heat and people like pass out and die when we make them mine gold for us. But space is right up there in like top 3 hardest environments to cool stuff in. You don't just do anything in space. Everything in space is hard. So why people like me focus on statements like this is, again, not because rejecting heat in space is impossible. We do that, as you can see on these solar panels, like in the ISS. I focus on statements like this because it's the kind of thing even a first-year engineering student wouldn't say. A consistent lack of appreciation for thermodynamics in public statements, to me, is indicative that people like Musk either don't know what they're talking about or they don't care. And either of which is concerning to me. If you wanted my honest opinion about why someone like Elon can double down on saying, well, heating isn't that big of a problem, space is big, it's because he's not an engineer. He's the head of a company trying to make a lot of money. Trying to pump up your company's products and sell them is fine, I guess, if so many people didn't think you're actually a genius engineer. You know what I mean? As a counterpoint, imagine you ask someone like my friend Dr. Mu here, who works at the Jet Propulsion Laboratory, who has spent the last 15 years sterilizing spacecraft so that we don't infect places like Mars with human stuff and the other way around. Dr. Mu here wouldn't say, oh, you just put a radiator on a satellite, it's not a big problem. I asked Dr. Mu, and she would say something like, yes, heat rejection in space is a very hard problem, but we here at NASA have come up with an amazing solution. Please stop cutting our funding for the love of God. What I'm saying is that for people like Sam Altman, who likens training AI to feeding humans for 20 years, or Musk, who seems to hand-wave the vacuum of space, these people could easily sound like they know what they are talking about, but they don't. And to me, that is a red flag before we even get into any of this technology. If you are as smart as everyone thinks you are, and you know the ins and outs of all this technology, what it can do, how to deploy it, etc., you should sound smarter than you do. And if you consistently don't, it confuses and angers me. And I think a lot of sciencey people like me. Back to the lab. But of course, it doesn't matter. It doesn't matter if I think Elon Musk's statements are weird. He is a deeply weird person. You are totally fine. You are allowed to be a weirdo and also a head of a company. That doesn't matter. What are the professionals at SpaceX actually going to do with orbital data centers? That's what matters, right? Doesn't matter what I think about anyone personally. So what is SpaceX going to do? Well, because the heat rejection problem is too big for anyone to hand-wave, really, with a large data center, what SpaceX is going to do instead is a bunch of individual AI or compute-laden satellites, each with enough compute on it to eventually equate the compute of a large Earth-based data center. And that's going to take years of launches and many, many, many invisible laser links among a mega constellation of satellites, which you got to admit is pretty cool when you say it. Now, in theory, and again, I want to be clear just with what when I said my initial evaluation of this idea, the big data center is silly. I want to be clear and be fair to this idea as well. In theory, this will work. There is nothing about science or physics that says that this can't happen. You can have a small satellite with some GPUs on it and cool it down in space. Now, what I am saying is that this idea is also impractical and kind of silly, even if you solve the heating problem. Which, to solve the heating problem for just one of these satellites, by the way, you need radiators about the size of an American football field, about 20 by 70 meters. That's a lot. But you can make all of those. You can make all of those radiators and solar panels. Okay, fine. So what are all these satellites actually going to do? Well, each one of these is going to have about a proposed, and I say proposed because they don't exist yet, proposed 120 kilowatts of compute. So this is just a power value. Power value also translates into the heat value because whatever you're producing, you also have to get rid of. But 120 kilowatts from onboard GPUs. So that's not that much, obviously. To get the compute of one large data center on Earth, you would need about a little over 8,000 of these. And this is about half of all satellites that are currently active in orbit. Now, I want to focus on that for a second. To do the SpaceX AI many satellite thing, to get the equivalent of one data center, one big one, you would need to almost double the number of, you would need to almost double the amount of satellites currently in space total for one. Okay. That's a lot of satellites, and that could be a problem, which we'll get to later. If you want to compete with Earth compute, in total, SpaceX says that they want to launch up to 1 million satellites. Not 8,000, 1 million. Now, there are many, many small challenges. Yeah, SpaceX alone has 10,000 Starlink satellites. That's true. SpaceX actually has the majority of satellites in orbit, and they would have to almost double it for one large data center. That's what we're getting at, chat. Now, there are many small challenges with putting this many satellites in space, but I'll focus on just the two big ones that I want to prove my point, or to try to support my argument here. First, I don't think, and I don't, a lot of the economics type people you ask point out the same thing. I don't think there is any way that SpaceX is going to make headway on launching this many satellites into space by the end of this year. That's what they say. They're going to start making and launching a good amount of these satellites into space by the end of this year. Why do I say that? Well, it's already June, and SpaceX doesn't have a working prototype of even a single one of these yet. That's one hurdle. The second hurdle is that Starship, the big spaceship that's going to take, 100 satellites into space at once, it has flown successfully 7 times, which means fly and then reuse the rocket later. You need to do that to bring costs down, way down, like 50 to 80% down, or else none of this is going to work, by the way. They have completed 7 successful flights. To get to 1 million satellites, they'd have to launch successfully 10,000 times. That sounds like a big number. The all-time record for the number of... We'll get to you why you roll. Don't worry. Kyle is being disingenuous from the start. We'll get to it. The all-time record for the number of rocket launches at anywhere in the world in one day is 6. Now, 6. Now, even 6, 7. Now, even at that rate, the most that's ever happened so far, it would take SpaceX 4.5 years of launching one rocket every 4 hours to get 1 million satellites into space. Again, I'm not saying it can't be done, but it's going to take the efforts of an industry that is in a better spot than hand-waving thermodynamics. And it's not going to be there, the industry, by the end of this year. Okay. Just why I'm still being skeptical of all of this and a little bit sassy is that the numbers here are enormous and very challenging, according to this idea. But before you day traders get to me, let's get to that. Before you rise and grinders get to me. But Kyle. Okay. The economics of orbital compute is definitely not a settled thing yet. Even if there were enough launches, okay? This is, and I'll link this down in the description, and I'll pin it later after this. This is a 14,000-word economical analysis of putting satellites into space, of SpaceX putting 1 million satellites into space. This is about 29 pages, and I read it all yesterday. You can read it all later for yourself, but here are some quotes. After giving 14,000 words of timelines and payloads and numbers and dollar signs to everything. Okay, let me make sure I'm highlighting. Thank you, Cal. Cal for the 10. I'll get to that in a second. Economics verdict. For now, with current technology and costs, an orbital data center would be an order of magnitude more expensive than a terrestrial data center. However, if certain aggressive assumptions come true, the gap can close. In a best-case scenario future, which is 10 plus years from now, orbital compute might approach cost parity with top-tier terrestrial cloud. It's unlikely to be cheaper in the near or medium term for general workloads. So, for the next decade, orbital compute would need customers who are willing to pay a premium. These might include defense and research clients, or perhaps companies valuing PR of being in space or strategic independence. Okay, so this analysis, again, you can read it yourself, but it is more than thorough. As you can see from levelized cost to compute, that kind of thing. In the near-term future, this is going to happen, but it is going to be A, hyper niche, and B, it is going to be a PR thing for SpaceX. This is probably going to happen, but it is not on track to replace Earth data centers or even come close to the amount of compute that Earth data centers have. And so presenting this as, well, the future, everything is going to be in space, right now is a little misleading to me. I haven't seen anything in any of these analyses that makes SpaceX a true trillion-dollar company that doesn't rely heavily on aggressive assumptions and aggressive timelines that seem very hard to meet. Like it or not, Elon is famous for promising scope, scale, and speed and coming up way short on all of that, no matter what you think of what SpaceX wants to do. To me, that's another red flag when you're talking about something like investing. Just ask your 401k. So, even if SpaceX succeeds in meeting all the aggressive assumptions we talked about, maybe I didn't actually outline what the super aggressive assumptions are. The super aggressive assumptions are all this has to come true, by the way. The Starship, which has only flown successfully 7 times, has to dramatically lower cost to low Earth orbit, dollars per kilogram. Satellite production has to be intensely streamlined, which they are building buildings to do so who knows. And we have to develop advanced lightweight cooling technology to address the cooling problem, which is still there. So even if SpaceX can do all that, the second big challenge that I want to focus on before we end, not just economics and scope and scale, but existential. There's an existential problem here. Like with AI in general. The other quote that sciencey people are focusing on from the IPO video, still you can see behind me, is when Elon and his engineers were saying, quote, when talking about filling space up, multiplying the number of satellites in low Earth orbit by 10 or even 100 times what it is today to do AI. Quote, there's a lot of space up there, so even when you're talking about thousands or, up to 1 million satellites, yeah, you've got plenty of room to move around. Space is really big, so it's not like space is going to get crowded. He's right. Space is big. But the space in low Earth orbit and the orbits that we want to put these satellites is not infinitely big, and in fact, it's already crowded because of SpaceX. Again, someone who is ostensibly an expert in the satellite launching business should know these basic facts about space because they're the people that cause the crowding, and it's suspicious when people like him continuously fail to acknowledge the issue. Again, it's not, I'm not saying it's an immediate deal breaker. It is just weird. Space is really big. It won't get crowded. Girl, you're the one crowding it. Today, there are over 14,000 active satellites around Earth. 10,000 of these have been launched by SpaceX. Just with 14,000 that are around today, around Earth, as you can see, not 1 million, just 14,000, space is already getting harder to observe for astronomers. The night sky is filling with light pollution for all of us. And tens of thousands of evasive maneuvers have to be made each year to avoid the kinds of collisions in space that could end rocket launches generally. And we'll get to that. This image is misleading. This one from NASA. Now, I'm no space doctor, although I am a doctor technically. I'm no space doctor. But if any single company wants to increase the total number of satellites by up to 100 times, that has to guarantee many, many more maneuvers, coordinations, and points of failure. Collision avoidance is an important factor here, and that's why I'm bringing it up, because if just one of these maneuvers were to fail, and they happen tens of thousands of times a year, just one, maybe from a solar flare that we cannot control or stop, and one satellite were to crash into another, it could eventually, not immediately, but it could make getting to space a lot harder, if not practically impossible. But Kyle, you haven't been reading this study is called an orbital house of cards. This is where we are now. This is before any SpaceX IPO stuff, but after Starlink. This study, 3 years ago, I'll link it in the description. It used the current number of active satellites to calculate the likelihood of a cataclysmic cascade of crashes in a constellation of calculating coordinated compute canisters. If any of these systems went offline or malfunctioned for some period of time, Lydian, thank you for the 19. I will try to get back to everyone's comments. I promise. Let me just finish my little presentation. I spent so much time on it. Just a second. I was so sick and I was working. Just one second. If we scroll to the top of page 10 here, now it's like we're giving a lecture. If we scroll to the top of page 10 here, did I pass it? Right now, just with the satellites we already have in space, the math with the current number of satellites shows a 17% probability of one or more potential collisions during a 24-hour period if any evasive maneuvers failed. Right now, in space. Nearly a 20% chance within 24 hours for something really bad to happen. Now, they further updated this paper with what they call the crash clock. And this is with the most current number of satellites in space. We are now at a crash clock of 2.5 days, which if you normalize that to 24 hours, that is now a 60% chance of one or more collisions in orbit during a 24-hour period if anything goes wrong. We're down to 2.5 days. This is accelerating quite a bit. Now, if you take their data and plot it as they did here, you can see where this trend is going. This is the crash clock. Chance of collision within 24 hours is on the y-axis here. Now, I'm no space doctor, but if we scroll to study page 4 here, I am a doctor technically, but if we scroll page 4 here, since there's nothing in the denominator for their equation here that they're using to calculate satellite encounter collision rates, I think it's safe to assume that increasing the number of satellites around Earth by 10 or 100 times is not going to increase the amount of time we have if something goes wrong. It's going to do the opposite. Without perfect synchronization between constellations of thousands of SpaceX satellites, if a single one of them, perhaps in the limit, malfunctioned for just minutes, maybe even seconds, it could cause a cascade of hypervelocity debris that would go off like a room full of rat traps and could effectively prevent anything from leaving Earth orbit, lest it be shredded by shrapnel. Now, I am being forceful with the Kessler syndrome problem here because I've seen experts estimate that the tipping point for this might be around 100,000 satellites. We're at 10. Tipping point might be 100,000 where something will inevitably happen. And SpaceX wants to do up to 1 million, but that's fine because quote, space is big. It's another weird red flag, you guys. I'm not trying to be a Luddite here with amazing hair, but if we're already in an orbital house of cards situation, committing to making it even less stable of a house of cards while dismissing the issue in the first place is weird. I don't think smart people talk like this. To be fair, if anyone could figure out how to put a lot more satellites into space, it's going to be SpaceX, who's already put the majority of satellites into space. But given the scope and scale and aggressive timeline, given their public statements, given what seems to be a drastic over-evaluation of many of these companies, and what other CEOs who are their direct competitors say, I have a lot of reason to be skeptical that anyone has truly solved this problem that this will ever be built out to match Earth-based compute. Basically, that any of the more futuristic statements that will ever come true. I think there's a lot of public statement red flags, scope and scale red flags, timeline red flags, and just the dismissal of very fundamental facts and figures about where we are should alarm anyone who's paying attention, in my opinion. But of course, why I made this little presentation today, and I can see this happening in real time in the chat, is because all the comments that I'm seeing on the first video that I made are saying that I'm the dumb one. So before we talk to you, let me just end on some other outside statements I came across while trying to put all this in context for myself. Here's one quote from an astrophysicist friend of mine, Ethan Siegel. Starlink, quote, the current biggest mega constellation, executed one collision avoidance maneuver every 2 minutes between 2024 and 2025. That sounds stressful. If we wind up with 1.23, 1.7 million satellites in low Earth orbit, collisions would occur dozens of times each day, barring perfectly executed avoidance maneuvers. That sounds stressful. Quote, the CEO of SpaceX also appeared to wave off concerns about overcrowding low Earth orbit, even after numerous reports have emerged about Starlink satellites having to maneuver away from each other. Matt Garman, quote, head of the world's largest cloud company, called the idea just not economical. There are not enough rockets to launch 1 million satellites yet, and we're pretty far from that. This is really intolerable, said Robert Massey, the deputy executive director at the British Royal Astronomical Society, when asked about tens of thousands of satellites being added to the night sky. This is absolutely the destruction of a central part of human heritage. Yee. Hey, chat. Lydian Melody, thank you for the 19. I'm curious whether they decided to be stuck with increasingly out-of-date hardware, spending the incredible amounts of money to service all of them, or commit to letting them burn up and constantly replace them. For a mega constellation like we're talking about that SpaceX wants to do, they are going to just let satellites burn up and replace them as they do so. I think the crazy figure right now is that 1 to 2 Starlink satellites per day burn up in the Earth's atmosphere. Which, of course, if you're pursuing that strategy and there's so many you can't service all of them, and your GPUs go out of date every couple of years, you're going to let them burn up in the atmosphere, which means you have to constantly replenish all of these satellites over time, which increases launch costs, timing, coordination problems, blah, blah, blah. I see old people, thank you for the tenor. Kyle, it would be interesting to see a companion stream like this taking the opposite position from the most steelman position you can formulate. That's a good idea. I would love that. I'm certainly not an expert in this space, in the space of space. I've thought about that before. And if you're a student of communication like myself, who is a doctor of communication, that is a good exercise. Think of a communication exercise. If you want to have a good message, think of what the strongest possible argument against your message is and address that directly. EMP shields. Yeah, there will be some non-trivial, but not actually all that much amount of shielding that all the SpaceX satellites will need just for protection from solar weather and cosmic radiation. But it's not going to be, as far as that economic analysis that I shared, the amount of shielding isn't going to be a significant percentage of the weight to LEO. That's biggin'. Thank you for the 10. We need an orbital recycling company that catches and throws them back into Earth's orbit. The fun thing is that it is... Sorry, I'm all... There we go. I'm all asymmetrical now. The fun part of the economics of this is that it's easier just to let all of this technology burn up in the atmosphere and just put new ones up in there, if this is your plan. But yes, I mean, my overall, when I and people like me focus on the heating and cooling problem, the Kessler syndrome problem, I know there's many people who are very familiar with this issue who say like, well, that's not, Kyle, that is actually solvable. You don't work in the industry. You don't know how that this can feasibly be done. And I agree with you. And I'm saying, I do believe that the heating and cooling problem can be solved for individual satellites, etc. I'm trying to take an either further orbit out and say that I think that even if you do solve the physical problems, there's larger economic and existential problems that I don't want this in the first place. Do you know what's funny? Actually, one of the there's a former Ben Nowak is a former SpaceX intern, and he just started a company that wants to put a bunch of orbital mirrors around Earth. And I was seeing experts, for some reason, say how terrible of an idea they thought it was and how it would be catastrophic just for the night sky and for astronomy. And fun fact, Ben Nowak is one of the little baby boys that I kicked off of the Mythbusters competition show in 2016. I knew he was going to be trouble. I knew it. That's why I kicked him off the show. Didn't trust him then, didn't trust him now. I was reading the article, I was like, wait, is this that little kid? Is this that kid that I kicked off of the Discovery Channel? It was. It was. You created a villain? I have some other stories about him, but I don't know if I can... Don't know if that would be technically accusatory. Hey Kyle, I'm working on a game with a fusion reactor on an abandoned space station that needs to be cold booted after the player wakes up or whatever. What would be different? Does it still spin a turbine? If you have a fusion or a nuclear fission reactor in space, yes, it can still move a turbine because it's not a gravity-driven operation. It's a pressure-driven operation. As you're heating up the working fluid, it's getting hot, and then pumps are moving that steam and hot fluid around and then pushing past a turbine and losing some of that energy. It's not a gravity thing. If it was a gravity thing, then the design of reactors on Earth would look very different, like a water tower or something, or like a dam or something. So, and like I said, I love some of you coming in with counterpoints. EV Unedited says, low Earth orbit is vast. It has 1 trillion cubic kilometers in volume. You can safely handle 100,000 more well-managed satellites before real crowding. Starlink shows that it's doable. I would have to disagree. I would say, given that Starlink is burning up 1 to 2 satellites per day and has to do tens of thousands of evasive maneuvers right now before 10 or even 100xing this, that gives me cause for concern. And a couple people have said, LEO is big, it's fine. Every time I look this up, the crowding problem of LEO is the first thing. So I don't know where some of you are getting these crowding isn't a problem arguments or numbers, but astronomer that paper we just went through says we're already in a LEO house of cards situation. We're fundamentally disagreeing about reality. And keep in mind, even though 1 trillion cubic kilometers is a lot, when each satellite is many kilometers apart, and you have tens of thousands of them, and they have to remain in those positions, the amount of actual space gets very crowded very quickly, right? Because the density is not just what if all of these... The density function is not just what if all of these satellites were in one volume. They're not. They have to be spread out over kilometers. And suddenly when you have 10,000 of them, if each one... imagine you have 10,000 satellites. There's already 14,000 satellites, and you're just in 2 dimensions. If each one has to be 2 to 3 to 4 kilometers away from each other, suddenly you already have tens of thousands of kilometers of on each side, making, a million square kilometers of surface. You see where I'm getting at. It scales up really quick when they have to be that far away from each other. Why do they have to be that far away from each other? Well, because they're big and they're moving really fast. A satellite goes around the Earth once every 90 minutes, guys. These things are going really fast and they're very far apart. So even though space is big, once you start putting things kilometers apart and they're traveling many kilometers per second, things get a little more crowded in this sense. Isn't just the amount of raw space being taken up. It's going to be hard to get yourself into a safe location in low Earth orbit with so many things that need to be spaced in these mega constellations that are already going at orbital speed. You know what I mean? I believe this constellation is not going to be in LEO. Space is not in 2 dimensions. I know that. But I was not going to try to calculate the geometry of a cube in my head in real time in front of you. You still have to... You know what I mean. What's the orbit? Do you have any idea how expensive it's going to be to get past LEO? See... People are pointing. You guys are having a great conversation. This is what I'm saying. All of these levers, any of these levers that you push, the problems keep popping up to me in my mind that seem like not just small engineering challenges, but giant scope and scale challenges. Well, yeah, you could have it in a different orbit, but then it's going to cost more, which means more launches, and they haven't done that many launches yet. And then you're going to have to rapidly scale that up. And then there's a pollution problem from 6 rocket launches a day, or 1 rocket launch every single hour, as Musk has said. That is non-trivial as well. Kyle, what happens when satellites re-enter Earth? Does all that material simply evaporate and pollutes the atmosphere, or can we salvage that? Says Jorge. When a satellite burns up in the atmosphere, the majority of it burns up in the atmosphere because it's going like Mach 25 or something, 25 times the speed of sound. But some of that material and some of the vaporized material does deposit itself on Earth's surfaces and in Earth's oceans, yes. I know that because of how many Russian nuclear reactors are at the bottom of the ocean. But that's a story for another time. What if we put this center on the moon? Will they be safe there? I'd be much more... Guys, to be clear, if the latency problem wasn't a thing, or it's not as much of a thing, putting a data center on the moon sounds way better than this. And not only that, you have a lot of other problems where you have to put it on what face of the moon, and how often is it actually interacting with satellite and downlinking to the... Yeah, there's a lot of other problems. Putting a data center on the moon strikes me as a less existentially problematic idea. I would prefer everything being underwater at the bottom of the ocean. The cooling is way better than in space, and there's nothing down there aside from tens of thousands of whale carcasses in a whale graveyard that we just discovered. Again, it's the dismissal. It's the dismissal of very fundamental concerns that concerns me. And it's weird. It's weird if Musk and these other guys and SpaceX engineers, if they, I don't know why they're not taking these problems seriously. Maybe they're just bad at communicating. I don't know. But when you say, when we're already in an orbital house of cards, and astronomers are like, please don't add tens of thousands of more satellites. And then you have these guys who are like, hey, we run a satellite company. This isn't a problem. No one's ever said it's a problem. That problem's a myth. There's some disagreement on what reality is somewhere. And that I don't like that. It's very, someone is wrong. Ocean is horrible from a security standpoint. Sure. There's other problems. Ichiro. But if a shark bites a cable at the bottom of the ocean, it's not going to lead to a cascade of orbital debris that knocks out all of our communications for 100 years. And again, won't ocean data centers be bad for ocean life? Yeah, that's possible. Yeah, even minimal heating of a localized area in an ocean or a waterway, freshwater, river, whatever, does have a significant impact on ecology. Yes, but Kyle, it seems like there's almost no upside to any of this. That is the other side of this coin. We could also, even though it's going to happen and they're going to pull us kicking and screaming, we could also not have data centers anywhere. That's option C. You know what I mean? There are certainly problems with ocean data centers, but the problems are far more tractable than the problems with space constellation of data centers. I agree. Put them with our best transfer cables in Antarctica. Look, I'm just saying, while we're arguing about the details, these guys are making $1,000 a second, and we could just not have that. That's option C. Option C sounds like no internet. Well, that's weird because we're on the internet right now. I'm streaming in 1440p without any orbital corporate cyberpunk future. Huh. Look, I don't mean to be a Luddite. I don't mean to be not as red-pilled as the day traders and the rise and grinders. I just see the future that's coming. And for one of the first times in my life, maybe your life, I don't know if I want it. Isn't that a weird place to be in? Remember when smartphones were first made and your dial-up internet you first connected on? There was an excitement. This is the first time in my life where there's near universal, and there's always been blowback against every new technology, right? Smartphones especially, social media especially. But I have never seen such universal disgust and lack of excitement for a new society-shaping technology. And for one of the first times in my life, I'm not looking forward to the future that is barreling down on us like a freight train through a tunnel because we can't see the shape of it yet. That's your bubble, Kyle? What bubble am I in? What am I missing? While you guys handle that question, where should I be right now? Let's go here. Oh, sorry. I want to see your let me see your beautiful faces. Coming up on the channel, while I have been sick, right before I got sick, I've been traveling a lot. And we're just starting to get to all of those travel videos. So coming up on this main channel here, next up we actually have an episode about data centers and water use. Another highly controversial topic that I think we did a good job on. That will be coming out. But I just got back 2 months ago, or a month and a half ago, from 14 days in Ukraine. I was inside the Chernobyl exclusion zone. I went inside the sarcophagus. I think I'm the first civilian to take 4K footage inside the sarcophagus in history. Look forward to that. We are putting a lot of resources into making that as bombastic and cool as we can. I'll get you some travel vlogs from Ukraine during wartime, inside the exclusion zone, inside the Red Forest. And then 2 weeks ago or so, 2 or 3 weeks ago, I was in Finland checking out the world's first permanent nuclear waste repository. You'll have a whole video on that. And then maybe next week or later this month, I'm going to check out one of the first small modular reactors to go critical in the United States. And I'm going to talk personally with the U.S. Secretary of Energy. And then maybe I'm going to go check out a company that makes batteries out of nuclear waste for space. So we have a lot of cool stuff coming up on the main channel. I hope that you will join me for it. My North Star here is just to try to produce as much educational and entertaining content as possible so that we can all move forward into this dystopia together. But nuclear is bad, and what about the waste? You can't have safe nuclear. See how easy it is to do for another argument? No. The difference between people who say nuclear is bad and people who say AI data centers in space or AI or data centers is bad is that we have the facts and the figures and the data about nuclear power that you can address because we've done it over decades. This is brand new. This is brand new, and we don't have the same amount of evidence to make the same kind of rebuttals to those comments, I would say. We are not prepared for the amount of jobs we're gonna lose and people who are gonna be without work. We're not prepared for the shift in the economy that's going to occur as a result of that. We are not prepared for the growing level of psychoses among our young people. We're not prepared for people to marry AI. We're not. This is a different beast. What would happen if you shot nuclear waste into the sun, says Ichiro? Not a necessary thing. First of all, nuclear waste, there's actually not that much of it. All of the nuclear waste ever produced by all nuclear power plants in the United States could fit in the square footage of 2 large Walmarts, which, if you've ever been to Arizona, we have enough space for 2 of those. And right now, the majority of nuclear waste is just on site at nuclear power plants, slowly decaying away in dry or wet storage pools. It could stay there for forever. It really could. It's not going anywhere. The neutrons, the gamma rays, the beta electrons, that's redundant. The beta radiation, that's not going anywhere. It doesn't migrate through the environment like other pollutants like heavy metals, mercury, lead, that kind of thing. It doesn't migrate anywhere. It's on site in these storage casks and storage pools, and some of it has been on site for decades. So taking all of that and launching it into the sun, which you would have to do by canceling out Earth's orbital velocity of like 30 kilometers per second, is an extreme. Not only is it unnecessary, it would be extremely expensive. I don't know. I think the shooting stuff into the sun Should I make an episode on that? I feel like there won't be enough there, but so many people like the shooting stuff into the sun. We could talk about the orbital mechanics of that, you know. On a more positive question, did you go to Xenopower? That's who I'm talking to, actually. And I might tour their facility, and I think that would be very cool. But why URL 86? I have nothing against you. I mean, you're asking good questions. It's totally fine. You can be positive, you can be negative. I'm fine with being incorrect if the data says that I'm wrong. Look, again, for all of this data center stuff, all of the orbital launching 1 million satellites into space stuff, this could all be the other way. All right. This could be, hey, you look up some papers from astronomers, and they're like, hey, we're totally not in a house of cards situation. It's fine. And then you could have other CEOs being interviewed in The Economist. And they'd be like, yep, Starship totally can carry all of those satellites in time. The timelines seem all right, and I totally trust Elon Musk. All of this could be the other way, but it's not. And until it is, you know, you could have a physicist at MIT being like, you know, actually heating and cooling, we have the technology to solve that easily right now with something the size of your hand. But it is not that. And until it is that, I remain skeptical. You know? More debunking episodes? Who am I, Mini Minute Man? He needs more hair on his face and his head. And he's more... You know what? I'm glad he's more popular than me. He reminds me of a young me. And he's doing boots on the ground debunking. Good for him. Hey, good for him. My hair's nicer though. Excuse me. No one is ever going to say they trust Elon in the scientific community. We did. We did before he became a very public, had very public, weird, problematic ideas and takes and inaccuracies. Everyone was on board, even me. I had a whole show at Nerdist about what Elon was doing. But once the cracks started to show, once the deliverables weren't delivered, once the promises were made and never kept, and then once you show yourself to be personally very weird, and if your personal brand is tied into the companies and the products, then it's hard to get behind any of it. You know what I mean? Are you a Democrat? I'll take anything at this point. Reusing rockets, Starlink was treated the same way, and SpaceX delivered on those. Yeah, reusable rockets weren't a thing, and then they became a thing. Still, I think the scaling issue, I think that's probably the biggest issue. Because, right, you could launch that number of satellites, same number of satellites that Starlink already has. You could do that. It would just take a long time and cost a lot of money. And then the argument isn't again, like I said, the argument isn't a scientific one. It's, does this make economic sense compared to Earth-based data centers and putting them somewhere that makes sense? That's what I'm getting at, right? I said this during the last, when we started. None of this is technically impossible. It's just, should this be... Is this as good of an idea as SpaceX is saying? What if this is all just a big nothing burger to drum up more conversations about SpaceX? You mean like trying to get a lot of money for your IPO while only offering a small fraction of your company to bump up the amount of money that you can get from people who are really invested in SpaceX as a brand and not actually have a good proposed ROI long term? What? What are you talking about? Huh? Who said that? Huh? Who said that? Sorry, I'm staying a lot longer than I usually do, but I haven't seen you guys in a long time. Are you guys having a good time? We could be doing other stuff. I feel like I'm Hassan Piker or something like that, just sitting here with a chat window. But if you guys are enjoying yourself, we can keep. NIMBY and politicians banning ground data centers are making orbital ones more convenient by the day. Well, they make them less socially problematic for now, until there's enough satellites in the sky that space is everyone's backyard all over the planet, and then we start having the same problem. And I know it's not the same thing as having a humming data center in your backyard versus something in space. I'm just saying, even if it's more socially acceptable, it doesn't mean it's more economic. And I'm not, again, I'm more of a plan C type of guy. I'm not saying put all the orbital stuff on Earth. I say, why have them in the first place? Hey, Chernobyl Archive. Yeah, hey, buddy. I'll get to your messages once I stop doing me this. You said this was a Physics 101 problem. Way to pivot. In the original video, yes, I did. Yeah, I said having a large gigawatts scale building in space, more or less, or something, an International Space Station kind of structure, was a Physics 101 kind of thing, which makes it extremely hard. It would make it extremely hard to do it that way. There is no fundamental physical impossibility with many satellites in space. But if you want to rewind a little bit, I go through some other problems that I consider to be problems. Why not just make a handful of large ones in space instead of a million little ones? Basically, the square cube problem of losing heat in space. Because as something three-dimensional gets bigger, its surface area only increases by the square, but its volume increases by the cube. So as you have more and more GPUs that are extremely hot, they're creating heat in 3 dimensions, but they can only lose it in 2 dimensions on the surface, radiating from surface and radiator panels and whatnot. So that rapidly becomes your whole thing melts down kind of situation. We already have a lot of data centers. The internet we're on right now thanks to data centers. Yes, but we have never seen a build out specifically for AI applications of this scale ever. Trillions of dollars, right? We could, if the internet is already as fine as it is, why do we need a 9 gigawatt data center in the middle of Utah somewhere? That one physics professor says that this Kevin O'Leary project in Utah could raise the nighttime temperature in the valley where this Utah data center is going to be, could raise the nighttime temperature by 28 degrees Fahrenheit. That's crazy. That is like terraforming. That is nuts. That's when you say, why can't we just have a big data center in space? Because 9 gigawatts is a lot. Excuse me. Space is cold, but how to transfer heat to it? Radiation, and it's very inefficient and it's hard. To be clear, I'm skeptical about the most aggressive timelines, but that's why Elon time is a thing. No reason to nitpick just on the timelines. Even timelines aside, 86, I'm saying that putting that many satellites in space is problematic. Existentially. And nobody wants it. And it would be really hard. And it's unlikely they're going to start doing it by the end of this year. And, like we said, there are going to be demonstration projects of this. China will probably do it. There'll probably be niche military applications, niche scientific applications. Having some compute in space is going to happen. I lost so much respect for you today, Kyle. Why? What did I say? What did I do? Why? Because I'm skeptical and I'm worried about multiplying the number of satellites in space by 100 times in the next couple years, and then one of them, a single one failing, and then what did I do? I just want to look up at the night sky and not see a bunch of crap. Would you ever consider moving to another country? And if so, what are your top 3? Finland, Japan, Phuket, Thailand. Yay, no more ozone layer. Starlink was already tearing up the atmosphere. Now we're going to multiply that by 100. There's also, if you are going to get to 1 million satellites in space, there is, and it's not the biggest problem, but there is a non-trivial amount of pollution you're going to add to the atmosphere if you wanted to do the maximum of 1 rocket launch an hour. Any way you slice it, that's still a lot of material you're putting into the atmosphere. It's, again, not the biggest problem, but it's certainly not just running a nuclear reactor somewhere. Chernobyl, what did it feel like in the sarcophagus? Once you see the video, you'll hear me huffing and puffing. Thanks for being here, Crispy. We'll be done soon. Going inside the Chernobyl sarcophagus was the hardest travel shoot that I had ever done, not because of the radiation, which was the highest ambient radiation rates I've ever experienced. You don't feel radiation. That's why I think people think it's spooky, because I was getting enough I got half a chest X-ray in 10 minutes just standing there. So that's kind of spooky, but you don't feel it. You see it on your camera, which is also spooky, but you'll see that. What made the sarcophagus difficult was to go into it. I had to carry my camera gear, which is non-trivial because you can't put anything down or sit down or remove your mask. Okay. Something that's hard about filming in the exclusion zone and the nuclear power plant, which I've now spent 21 days at, which is kind of crazy. Because everything's contaminated, you can't touch anything, you can't put anything down, you can't sit down and take a rest, you can't take your mask off. Now, combine that, I am wearing shoes that don't really fit because they have to be, they're washed daily. All the workers use them. They're general shoes. I'm wearing shoes that don't fit. Over those, I have booties that are kind of slippery. On top of that, I have one pair of long underwear and then a pair of pants that don't fit so good. Then I have a shirt that is buttoned all the way up to my neck. Then I have a jacket that is buttoned all the way up to my neck. Then I have a very form-fitting mask. Then I'm wearing a helmet, and I'm wearing something to cover my hair, and I'm wearing gloves. On top of that, I'm carrying all of my camera gear with one arm, which is non-trivial. And I have a helmet on with a GoPro on. And then they put on a full winter jacket on top of me. Going through that, going up and down multiple staircases, ducking your head, crawling amongst debris while trying to not touch anything, not drop anything, not put anything down. If I were to drop my camera, I would have had to have left it there in Chernobyl. So you'll hear me huffing and puffing in the video. It was very, and I don't lead, I kind of lead a sedentary lifestyle, but I'm in fine shape. It was still extremely hard. And then after that, they're like, hey, you want to go see the drone strike hole in the NSC? And I was like, fine. And then they were like, oh, hey, the elevator's broken. So we had to walk up 40 flights of stairs. Or maybe 20. But, you know what I mean. 400 meters. No, sorry. 120, 130 meters, 400 feet. How much of that protection is actually needed to just follow the rule versus just following the rules? That anything you see a worker in Chernobyl wearing is not for shielding. That is for contamination protection. So if you were to get some contaminated dust or you scratch something or whatever, it's so you can take off your clothes and then that contamination is gone. You're not wearing anything for real shielding. Because, and this is my point about LNT and Alara, which we've gone through, as long as you keep your dose below a reasonable limit, it's fine. You don't accumulate that dose over the course of your entire lifetime. That's why people in Chernobyl can rotate in and out, working 1 week on, 1 week off, that kind of thing. But we still have regulations that say, oh, in a year you can't get this much radiation. But if you normalize that to microsieverts per hour, you can get a fine level of microsieverts per hour. It's not so bad. Yeah, and to be clear, we were there. I got very special access to Chernobyl and the sarcophagus because I was there with a humanitarian aid organization that we raise money for. That's the one that takes care of the dogs of Chernobyl. We also did a full Dogs of Chernobyl program, and I'll be bringing you full video of that. We sterilized 227 dogs and cats in the Chernobyl area to take care of those populations, make sure they don't spiral out of control. I have full video of the full surgical suite and interviews with the veterinarians and lovely footage of the cute little dogs and cats. We have all of that, and we'll use that to raise some more money for the Clean Futures Fund. Hey, Kyle, thanks to you, I bought a radio code, and within 2 days of receiving it, I found a secret nuclear waste storage facility less than a mile from my work. It's pretty fun, huh? This is the whole reason that I hate the whole getting rid of Alara thing, when Alara literally says reasonable. So staying below a reasonable limit was already logical and good. You don't try to get to zero radiation with Alara, says Adusek. Not true. The problem, well, I get what you're saying, but the problem was that reasonable was never defined, and over time, reasonable kept getting down-regulated, lower and lower and lower and lower, with the cost of trying to get radiation lower and lower and lower, increasing substantially the more quote-unquote safe you try to make it. Once something is generally clean, it costs a lot more money to make it exceptionally clean, and then it costs even more money to make it like perfectly clean and perfectly, radiation zero. So even though reasonable sounds good on paper, in practice over time in the nuclear industry over decades, reasonable kept getting lower and lower, which costs more and more money. And given the biological realities of low-level ionizing radiation, people like me are saying that you don't need to do that, and you can save money and time and regulation and red tape by acknowledging the biological realities of low-level ionizing radiation, and that Alara has outlived its usefulness because of its entrenched, its entrenched regulatory momentum has now become something that is too unwieldy, I think is the argument. How much of nuclear's price explosion was due to Alara, and how do we know it wasn't project management failure, says Mats. Oh, the majority of a cost of a nuclear power plant is not directly related to lowering the person sieverts of your staff. No. A lot of that is due to heavy government regulation, problems with public siting, public comments slowing down approvals, NRC not getting the things quickly enough. But Alara and LNT, the mindset that nuclear is something that is inherently super dangerous and you need to regulate it into the dirt, that does play into why nuclear takes long to build and is so expensive. It's because people have a perception of its risk, and that risk costs money, and a lot of people, communities don't want it in their area, so it takes time. And politicians, you know, they may or may not know what the hell any of that is, right? But as you can see now, at least in the United States, the tide is very much turning towards more nuclear power. And if you want a full discussion on whether or not nuclear power is actually too expensive and too slow, we have a whole video on it on the channel, if you want to check that out. You are older than the Chernobyl incident? No. No. Chernobyl incident happened 40 years ago this April. AI data centers are driving the need for more nuclear power. More power, yeah. So more power is going to use more water regardless. Not regardless, but it's all intertwined. But if you had to, when I bring up the water, I mean, AI data centers are going to need a lot more power, and a lot more power is going to bring along with it all of the complications that getting more power is going to bring, regardless of its of whether or not it's fossil fuels or nuclear or renewables. I would prefer that those energy needs to be met by something like nuclear and renewables, because even if they are using similar amounts of water, for example, I still prefer the upside of waste not going out into the environment, it being carbon free, the energy being the fuel being very energy dense, it being rock solid, firm generation capacity factor kind of stuff. So, and we'll go through this in the data center water episode, but not to mislead you, even a bunch more nuclear power is going to, for example, use a lot of water, just like all thermoelectric power generation does. But I would still prefer it to be something like nuclear as opposed to any kind of fossil fuel because of the upsides. What if people put AI data centers at Chernobyl? Well, given that Russia's already fine with striking it, I don't know if that's a great idea. Is the water issue the biggest issue at data centers? We'll go through that in the upcoming episode, Mech B. But to me, no, it is not the biggest issue. There is different... the power requirements seem to be a much bigger issue. Heating and cooling in local environments. And then, of course, the existential problems of having AI in the first place. Built out to be a significant portion of the economy. I think focusing too much on water use can obscure some of those other problems, and I think we want to focus on those other problems. Your hair is more powerful than any data center could be. Preach. All right, chat. As I said, I've been sick for the last few weeks. I apologize for not being here, but I think, and I keep futzing with myself, what was I going to say? I've been wanting to do this this topic for a while. I know I've been gone for a little while. I hope it went somewhat smoothly. I know there's a lot of discussion in chat. You can continue that in the comments. If you want to talk to me about this or any of our experts about this, you can join our Discord at patreon.com/Kyle Hill. I hope you liked this return to a live streaming kind of format. Hopefully my voice hasn't been too cooked. But I really appreciate all of you being here, all of you asking really good questions. And like I said, there's a lot of good stuff coming up on the channel, especially travel videos that were really hard, and I'm really proud of it. So I hope until the next time I see you, wherever that is, another live stream, another video, another gaming stream. I hope until then... Kevin, turn that down! I hope you have a wonderful rest of your day, your night, your evening, whatever. I will see many of you soon back inside the facility, but no matter when I see you next, I hope until then you have a wonderful rest of your day. And please, especially online, be nice to each other. Because this is all we got. Unless we're just conscious AI versions of ourselves floating in space. Bye! Love you!